happens when a reaction is at equilibrium and something changes? For example, you are adding reactant or you're removing product or you are increasing or decreasing the temperature or pressure. How does that affect on the reaction? This is for this you need to know Lee-Chatelier's principle, and what this Lee-Chatelier's principle is that when a change is imposed upon a system, your reaction is your system. When a change is imposed upon a system, the system adjusts itself in such a way so as undo the effect of the imposed change. System, the reaction doesn't like the change. That reaction is trying to get rid of the change that you brought on it. So we're going to discuss the effect of change in concentration, temperature, and pressure on equilibrium. For example, let's take this reaction into let me go to the next slide. This table summarizes the effect of concentration, temperature, and pressure on the equilibrium. So let's discuss first the concentration. So for example, let me take this reaction. 2CO plus O2 gives 2CO and 2CO2, I'm sorry, and this reaction is at equilibrium. Let's say what I'm doing is I'm adding more reactants, I'm adding more CO. If I add more CO, means I'm adding more reactant. That additionally added reactant, what it's going to do is going to start combining with oxygen to form the product CO2. So that means, can we say that on adding the reactant, equilibrium favors the product, means you start making the product. How is adding of more reactant is going to affect the concentration of oxygen? Since you are adding more CO and it has started reacting with oxygen, that means the concentration of oxygen will decrease while the concentration of CO2 will increase. Let's look at removing the reactant. What if you're removing that? So here, this was CO2. What if you are removing CO? If you are removing CO, now the system wants to make CO. Remember, the system doesn't like the change. System is going to try to get rid of the change you made. So if you're getting rid of CO, then the system is going to make CO. And how the CO can be made? If the reverse reaction will go. That means CO2 will start breaking down to form CO and O2. So that means we can get CO back. So that means when you remove the reactants, equilibrium favors the reactants, is going in this direction. Similarly, think about adding products. If you're adding carbon dioxide, system wants to get rid of that carbon dioxide, means it's going to start breaking down to form the reactants. You're adding product, equilibrium is favoring the reactant. If you remove the product, that means the reaction wants to make it because you removed it, so it wants to make it. How can you make CO2 if your reaction goes in this direction? Means equilibrium favors the product. So this is the effect of the concentration. The next we're going to discuss is the temperature change. Now, in order to predict what effect a change of temperature has on a reaction, first you must know if a reaction is endothermic or exothermic. So let's say, I'm going to take this reaction. So now I'm going to talk about temperature effect. N2 plus O2 gives NO, 2NO. And delta H for this reaction is plus 43 kilocalorie per mole. Now, what does delta H positive means? Means the reaction is endothermic. So again, important thing is to find out whether it's endothermic or exothermic. So let's say now we know the reaction is endothermic. So what if you are increasing the temperature of this? Let's say in a vessel you have N2 and O2, they are combining, forming NO. NO is breaking down to form N2 and O2. So here, let's say you start heating it, you're increasing the temperature. If you increase the temperature, remember it's an endothermic reaction, you assume that your heat is on the reactant side. When you're increasing it, what happens? Equilibrium favors the product. Increasing the temperature of an endothermic reaction favors the products, means you're making more products. Decreasing the temperature will favor the reactant. Let's say take another example. For example, I'm going to take one exothermic reaction example. Now, exothermic reaction, for example, N2 plus 3H2 gives 2NH3, and delta H for this reaction is negative 22 kilocalorie per mole. Negative value means this is an exothermic reaction. So if it's an exothermic reaction, let's say what happens when you increase the temperature. For exothermic reactions, if you increase the temperature, equilibrium favors the reactant, means your reaction will go in this direction, means to the left side. For if you decrease the temperature, if you're decreasing it, for exothermic reaction, equilibrium favors the product. This is the effect of temperature. Keep in mind, for this you need to know first whether it's an exothermic reaction or the endothermic reaction. The last one is, how does the pressure affect the equilibrium? Now, so I'm going to take this example. N2 plus 3H2 gives 2NH3. For uh, for this pressure effect discussion, first you have to look how many moles are present on the reactant side and how many moles are present on the product side. These are your reactants. 1 mole of nitrogen and 3 moles of hydrogen, means total 4 moles are present on the reactant side, and we have 2 moles on the product side. So for this particular reaction, so let's say if you increase the pressure, so let's say again in this reaction vessel, this reaction is going on, and you increase the pressure. Pressure means you're putting pressure on this. You can use a piston to put the pressure. If you're increasing the pressure, equilibrium favors the side that has fewer moles. Which side has fewer moles? The product side has fewer moles, so the equilibrium will go towards this side. Because when you're increasing the pressure, you're making less volume, means it favors the side where there are less number of moles. On the other hand, if you decrease the pressure, means you're getting rid of some pressure from here, you're decreasing the pressure, then equilibrium favors the side that has more number of moles. So for this particular reaction, if you increase the pressure, then the reaction will go in the forward direction. If you will decrease the pressure, the reaction will go in the backward direction.
Made with Doodlecast Pro.